Hey, the first part of this video, just go through some of my rethinking about how I connect the remote sensor nodes, the ESP32s, through wireless technology. So the plan was to use Lorawan, finding some problems with coverage with that. So the next part of this video, I'll just go through some of the alternatives, which include Sigfox and NB or narrowband IoT. We'll see how that works. But as I say in this, I still plan on going through doing the Lorawan version of this because I still need to cover off on getting the actual ESP32 reading sensor data, reading GPS data, sending it up to the server, and then on the Firebase and Angular side of things, I still need to process the data the same way there. So it'll still be good to go through the Lorawan part of it. And again, as I say in the next video, any of these other two methods, Sigfox and NB-IOT, I can should be able to wrap them up in libraries. So as far as the actual code on my device, it shouldn't need to be very or any different between using the three methods. Hopefully I can just set a flag and have the device send whatever method makes sense for connectivity. At the moment, the ourLora project will still be using Lorawan. But the purpose of this project was to set up a remote IoT device on my boat that communicates through Lorawan, which is a low power wide area network. One problem I ran into was out at my dock there's no Lora gateway close by where it can actually send Lora transmissions. It's not going to be easy to set up. If you're doing this as a commercial enterprise, you'd probably talk to the marina and put a Lorawan gateway in at the marina to cover all the boats in the marina. But I'm just hacking around, so I won't be doing that. So at the moment, things for the ourLora project will still go down this route of having a Pycom board that has sensors in the boat, picking up information. At the moment, going through Lorawan, going to the Things network, which decrypts the payload and sends it on to Firebase cloud functions, which receive the post from the Things network every time something gets transmitted from the Pycom board. That then goes over to sent to a Firebase Firestore database, and then I'll have an Angular front end. That's just the same as I covered it in video 2. But because I'm having trouble having that connectivity between the board and a local Lora gateway, I've got a couple of alternatives. So one thing I'll be looking at, and part of this will be changing using the LoPi4 board to using either a GPy or a PhiPy board, which includes, as well as Lora and Sigfox, has cellular connectivity, so I can use narrowband IoT connectivity and Sigfox. So first I'll try out using Sigfox, and this is basically what Sigfox looks like. So similar sort of low power wide area networking. Instead of using spread spectrum, it uses narrowband transmissions, but same sort of thing, just small packets being sent slowly up to a local Sigfox provider, and they send the data on to Sigfox, which provides the back end, which does things like decoding the packets and then sending it on to the cloud service that I'm using. So again, would send the data on just the same way to Firebase functions, and then Firebase Firestore, and then Angular in the same way. So the nice thing about this is I could write a routine that I can just flip between using Lorawan and Sigfox. In the actual code, just flip the library or switch in the library to say whether I'm using Lorawan and Sigfox, and it should all appear at the Firebase gateway either way. So I think I'll try that out. I do have some doubts about Sigfox just because they basically own that middle tier there. They're the only one who provides the service between the actual gateway for Sigfox and my cloud services. So I have some doubts about being locked into Sigfox for that. So the third alternative is again swapping to this GPy 5Pi board. It now opens up some network providers like Verizon and AT&T to me, and I can use the narrowband IoT protocol. Again, it's a low power wide area networking protocol just for sending slowly small packets. It's a bit more power intensive than these other two, but the coverage should be the coverage provided by all the normal cellular providers. So this would send cellular information up to the local provider, and I'd also use the hologram service. So they provide SIM cards for the connectivity. They kind of work as a third party with the bigger providers like AT&T and Verizon, who really don't want to see one-off IoT devices and don't really provide support for that. So hologram provides that middle tier of providing SIM cards and a service, but they also provide a middle tier for processing the data coming in, and same way send it on to a cloud provider like again my Firebase cloud services. That might put me into the same sort of box as Sigfox. This one's a little bit more expensive, but we're talking about $1 per device per month. This one, I'm not sure of what Sigfox charges. Lorawan, in theory, could be free if you have a local Lorawan provider that connects up to the Things network. So those things I'll be trying out. So I'll still be going through the ourLora project, putting it all together, because I need to do a lot of work on making the actual node, writing the code for it. I think I can use the same code for both of these. I still need to do this back end. So again, if it all comes in through the same Firebase cloud functions, then it can all be done in the same way. So this I'll all do in ourLora. But after that, I'll probably make another project called, it's looking like Our Boat Monitor is going to be the name. And so taking the technology out of the picture and just trying out these other technologies as well. So the rest of this video I have a look at how I'm getting GPS connections. So I've swapped over to using the PyTracker Pycom expansion board. Still using the Lora for Lora and Sigfox wireless connectivity. So let's have a look at the code. So to get started on using the GPS on the PyTracker V2 board, I went to this GitHub repository. There's a link on the Pycom site to this. And I went to the PyTrack V2 folder, which has the code related to that expansion board. And there's a couple of things here. So there's main.py, which is a good example of using the libraries that get information off the GPS. And I also brought in the lib, and that has various libraries here. So PyTrack is the main entry point to talk to the PyTracker board. It actually is a wrapper around this PyCo proc routine. So you see here PyTrack is really just encapsulating that PyCo proc library, and in PyCo proc it has most of the routines for managing the PyTrack V2 expansion board as well. I bring in these libraries. So this L76 GNSS library has specific functionality for interfacing with the GPS, and this one here LIS2HH12 allows you to interface with accelerometer. I'm not actually using the accelerometer for my project, but I use this library just to turn the accelerometer off so it's not using power. So I need to bring those into my project, so let's have a look at that. Okay, so this is the project I'm initially using for playing around with the PyTrack V2 board and the GPS. It's actually in a project called Sigfox, because I'm also working on getting Sigfox wireless going with this, and I'm actually going to talk about more of that in the next video, ourLora04. But let's just look at the GPS specific stuff that I need to set up. So basically from the GitHub repository that Pycom provides, I cut down the code that they had in their main.py, brought it into my main.py. You'll also see a bunch of stuff to do with Sigfox in here as well, but I did things like open up those various libraries I was talking about, so I could basically open them and then either de-int them for things like the wireless LAN. I didn't want to have that using power. I'm not using the wireless LAN. For the accelerometer here, I wanted to turn off the accelerometer, so it wasn't using power. Ignore the Sigfox part, I'll talk about that in the next video. And then I went and put together this library PyTrack Helper, where I'm doing my main wrapper for talking to the GPS on the PyTrack 2 board. The PyTrack Helper has a function that I put together called get GPS, and the things I need to pass that is the Py class. So you see up here, the Py class was initialized from the PyTrack library. And I also passed a number of GPS checks I should do to see whether I've got a longitude and latitude coming in. Just because the way GPS works, when it first starts up or gets powered on, it takes a minute or two for it to get its first GPS coordinate. So what this is actually doing is just cycling through every second or so, seeing whether it's got GPS coordinates, and then we'll have a look in the PyTrack Helper get GPS code. But the other thing I'm doing is, once I start to get longitude and latitudes, I only get 10 samples and then take the one that I most often see, which is most likely where I'm actually located, and then return that as the longitude and latitude. And the rest of this is mainly to do with Sigfox. I'm going to skip over that until the next video, but let's have a look here at the last part before finishing the main routine. Is I call this Pi, which is again is the PyTrack 2 board, set up sleep routine, and give it 3,600 seconds in this case, which is basically sleep for an hour, or it's telling it the sleep period will be for an hour. It hasn't slept yet. And then I call go to sleep, and go to sleep is a special routine again in those libraries associated with that PyTrack 2 board to turn off things like the accelerometer, the serial port, anything using power. And because I say GPS equals false, it also turns off power to the GPS. And also at that point it actually goes to sleep, so I'll put the board into low power mode at this point, and I'll do a reset. So this is a lot like machine deep sleep, but is specific to the using it for that PyTrack 2 board. At that point it'll go to sleep for whatever duration I set, so 1 hour, and then it's gonna, when it restarts, it's going to restart right from the beginning of main again and go through this whole routine again, set up the connection to the board again. And this is kind of what it looks like when it's running. So you see here it went through a lot of iterations. Doesn't normally take this many iterations till it started to get GPS information coming back from the board. And you can see here if it keeps getting the same longitude and latitude, it just counts up how many times it got it. Once it gets to 10 samples, it's going to run through, find the coordinate that it saw most often, which should be the one here that here it saw 5 times, and that's exactly what it found. And again, because I'm playing around with Sigfox, it sends the information through Sigfox for further processing. So let's go have a look at this PyTrack Helper routine. Okay, let's have a look at the PyTrack Helper routine. So this uses a lot of the code that was coming down from the GitHub repository provided by Pycom. I import a bunch of libraries, and I'll just concentrate on routines that I added in. So I added a blink routine to be able to blink the LED while it's doing things. I added this most common coordinate routine for finding the most common coordinate that gets returned from the GPS when I'm working out which one I actually want. And this is the main routine that gets exposed. Get GPS, and you pass it the Pi object. We saw that just before. and the maximum number of samples to get, so how many times to go out to the GPS and try and get longitude and latitude. Some initialization here, some constants being set up, get a real-time clock set up, import some libraries, especially this reference to the L76 GPS library, and then goes into this loop for sample number and range maximum samples. So again, I pass in however many samples or checks I want to do on the GPS to try and get the coordinates. It gets the coordinates by calling the L76 objects coordinates routine, returns coordinates. If it wasn't able to get coordinates at that point, it's going to return none and none as the coordinates, and basically I flash the LED red at that case, just print that it's bad coordinate, don't do anything else. If it does get a good coordinates coming back, then it increases the count for the number of coordinates that I've actually collected, and then it checks in this directory or dictionary of coordinates. If they already exist, then it just adds 1 to the count for those coordinates, otherwise just sets up a new coordinate in that directory and give it a value of 1. Keeps going through. Once it has got 10 valid coordinates returned by the GPS, and that's when I go and find the most common coordinates. So usually you'll find that the GPS, after 2 or 3 coordinates or checks for coordinates, usually it hones in on just a single longitude and latitude. So that's what this is returning, the one that it sees the most often out of, in this case, the last 10, and then it returns that to the main routine. So that's the PyTrack helper. Again, we saw that was working earlier. So there's the code for getting the GPS going. I kind of like the PyTrack 2 board, just because it's got so much on it. It doesn't really cost a lot. I could never make a board for that price out of discrete components. So it gives you the GPS, gives you the I2C interface, for which I'm going to use on my boat application to add a humidity, pressure, temperature sensor. You can also still do the normal Pycom board type of things of getting voltages from the I/O pins, or find out where the switches are open and closed, so you can still do that stuff on the board. Also has a battery, lithium-ion battery interface, so I can have a lithium-ion battery connected up to keep it alive even if the main voltage disappears, and has a serial connector for actually programming. So an awful lot of stuff on a board, the PyTracker board. So that's the one I'll be using. So that's about it until I wrap all this stuff together. I'm still working on the wireless stuff, so you'll see in the next video I'll be looking at the Sigfox wireless connectivity. Still using the same project, but I'll dig into what I was seeing with Sigfox. And then there's one other IoT wireless technology called narrowband IoT. I'll probably also go off track and go have a look at that in the video soon as well. And then I'll put everything together for the ourLora application, which is looking like it's going to be called something else, because I probably won't be using Lora as the wireless technology after looking at the choices.